All right, why negative powers and zero powers actually make sense. A lot of people have issues with this. They kind of know the rules, like if I have a to the negative n here, it's going to end up being 1 over a to the n. My power becomes positive, and we know that anything to the power of 0 is 1. Okay, just a couple examples. So x to the negative 3 is going to be 1 over x to the 3. 5 to the negative 2 is going to be 1 over 25, or 1 over 5 squared. And then anything to the power of 0, like 13 to the power of 0 is 1. Okay, but why is that the case? So if we take a look here, and we break down 2, we all know 2 to the power of 1 is 2. 2 to the power of 2 is 4, 2 to the power of 3 is 8, and what's actually happening from here to here to here? Well, I'm just multiplying by 2. 2 times 2 is 4, times 2 is 8. If I went 2 to the power of 4, it would be 16. If I went 2 to the power of 5, it'd be 32, and I just keep multiplying by 2. So naturally, it makes sense if I'm going up in power, I multiply by my base here, but if I'm going backwards or dropping a power, then I should be dividing by 2. 8 divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. So this follows the pattern. 2 to the power of 0 should be 1. What about negative powers? Well, let's keep going. If I divide by 2 again, I'll get a half. Divide by 2 again, I get a fourth. Divide by 2, I get an eighth. Okay, and I stay consistent here. As I drop down by 1 on my powers, 0 minus 1's negative 1, minus 1's negative 2, minus 1 negative 3, and I continue the pattern here.